In this video, we're going to take a look at evaluating piecewise functions. You may be familiar with evaluating functions where we have something like this: f of x equals 2x plus 1, and then it says evaluate when x is 3, or find the value of f of 3, for example. And remember, what we would do there is we would take that 3 and plug it in everywhere that we see an x in our function. So this would become f of 3 equals 2 times 3 plus 1, and then we could simplify that. With a piecewise function, the difference is that we have to figure out which piece of that function, so the piecewise, we're going to use depending on the x value that we're going to plug in. So for example here, this first one, we've got f of negative 3. So in f of negative 3, we have to figure out first, which of these does the negative 3 fit into for the x? So if x is less than 0, then we're supposed to use this top one. If x is greater than or equal to 0, we're going to use the bottom one. So for negative 3, if we check, negative 3 fits in right here. So that means we're going to use this top piece. And so f of negative 3 is negative 3 times negative 3, or holy cow, times 3, negative 3 plus 5, something like that. Okay, and then we just simplify, so just follow the order of operations. Negative 3 times negative 3 is 9 plus 5, and finally 9 plus 5 is 14. So for this piecewise function, f of negative 3 equals 14. Okay, let's try the next one. If we're looking for f of 0, again, we have to check and see, where does 0 fit in these inequalities? Well, right here, 0 is greater than or equal to 0. It's equal to 0. So that means for 0, we're going to use the bottom one. So here we go. Plug in 0 everywhere we see an x. So it's 0 minus 3. And then we have 0 minus 3. We simplify that, and that is negative 3. So that means f of 0 equals negative 3. How about this last one, f of 2? All right, so where do we fit? X is greater than or equal to 0. Yep, that's where 2 is, because 2 is greater than or equal to 0. So we're going to use that bottom one again, plugging in the 2 for everywhere we see an x. 2 minus 3 is negative 1, like so. Okay, let's slide over to the other side here and see what we can do with these and the g of x. Now, this one has 3, so we're going to have to check a little bit closer to see which piece we're going to use for each of our x values. Remember, here's the number that we're checking. So g of negative 3, so we go to our function g, and we see, okay, where does negative 3 fit in? X is less than or equal to negative 3. Oh, and we've got negative 3, so we're going to use this one right here. All right, so plugging in negative 3 everywhere we see an x. Now, we got to be careful on this one because we have negative x, and then we're putting in a negative 3. So that negative stays out front there, and then we put in a negative 3 for the x, and then plus 1. So we have negative negative 3, which is going to become plus 3. So we have 3 plus 1, and that will simplify to be just 4. Okay? All right, let's try this next one. G of negative 1. Where does the negative 1 fit? Okay, well, negative 1 is between negative 3 and 2, so we're going to use this middle one. Now, wait a second. You say, where do we put the x? Well, there is no x, and there's just that constant 7 there, so g of negative 1 is just equal to 7. And any value that's between negative 3 and 2 would also give us 7. So for example, if we put in 0 for g, or for x, excuse me, then we'd get 7. If we put in 1, we would get 7, and so on. So lots of different x values in the middle there will give us just 7. This last one, g of 5, where does that fit? You might notice I kind of went in order here. 5 is greater than or equal to 2, so it's going to be this bottom one. So go ahead and plug in the 5 everywhere we see an x. So 2 minus 5, that gives us negative 3. So we have our value. So when we're evaluating piecewise functions, remember it's very similar to these that we've done previously, except that we have to figure out which piece of the function are we going to use. And that depends on the x value. Which of the inequalities make that true? So when we put in -3 is less than 0, so that one works, and so on. Keep working carefully on this stuff. Be really careful with those equal to and just the inequality symbols, so you don't mix up where that -3 goes. Remember that -3 is in the equal to part there, and you can do this.